This is going to be the third part of section 2.2. We're still using the constant and power rule. The only difference now is we're going to get into fractional powers and root powers. So one thing that we have to real quickly review is that when you have a root, that is the same thing as a fractional power. So if I give you, say, the square root of x, that's the same thing as saying x to the 1/2. If I give you the third root of x, that's the same thing as saying that x to the 1/3. So essentially, the bottom of the fraction will always be determined by what root you're taking. The top of the fraction will always be determined by what the power is. So for example, if I gave you, say, the third root of x to the 5th power, that would be the same thing as saying x to the 5/3. So notice the 5 is the one that goes on top, the 3 is the one that goes on the bottom. Okay? And that comes from our properties of exponents. I know that the third root is the 1/3 power, so that would be like saying x to the 1/3 to the 5th power, and then we multiply our powers to get x to the 5/3. So this is going to be important for you being able to transfer these in order to take these derivatives. So the other thing that is going to be a challenge for us is making sure that we understand how to subtract 1 off of fractions. That's really important. So this first one is already in fractional form. So when we take the derivative, our y prime is going to be equal to 4/3. We do the power rule exactly the same way. And then when we subtract 1 off of 4/3, hopefully you understand the concept that 4/3 minus 3/3, that's 1. 3/3 is 1, is equal to 1/3. So the power that we end up left with is 1/3 power. So we have 4/3 times x to the 1/3. We will not change this back to a root right now because we weren't starting with a root. If it starts with a root, then you're going to want to make sure it ends up as a root. So that's where it gets a little bit challenging, is making sure we simplify these correctly. The derivatives themselves are not that difficult. It's just making sure we subtract powers correctly, subtract fractions correctly, and then simplify correctly. Okay, so we have another one here. We have 3 times x to the 2/3. So what we will do is we will be multiplying 2/3 by 3. So it's like 3 times 2/3 x, and then we subtract 1. So it's going to be 2/3 minus 3/3, which gives us negative 1/3. So this is going to be to the negative 1/3 power. So we have a little bit of work to do here. Okay, so we do 3 times 2 is 6. 6/3 is 2. So therefore we're left with a 2 on top. And now I'm going to bring my x to the bottom. So we have x to the 1/3 on the bottom. So very similar to what we were doing before. Negative exponents work the same. We should clear every problem of negative exponents if possible. Okay? So part C, we have the square root of x. So our first step is to rewrite our problem as x to the 1/2. Then we do our derivative. 1/2 times x minus 1 off of 1/2 is going to be negative 1/2. So notice we have our 2 on the bottom already. So we're going to be left with f prime of x equals 1 over 2x to the 1/2. And then don't forget, we need to change this back to a root. So it's going to be, our final answer is f prime of x is 1 over 2. And then x to the 1/2 will change to the root of x. And again, you don't have to keep all of these steps in here. You're allowed to skip steps. I'm just trying to make sure I show everything to you so that way you won't get confused. Okay, this last one, same thing. First, rewrite your problem with an exponent. So this is going to be x to the 4/3 power. So now we take the derivative of that. F prime of x equals 4/3 times x. We minus 1 off that. We get to the 1/3. We don't have to move anything because we're already good there. So we have 4/3 times the third root of x is what our f prime is equal to. So again, these are pretty quick examples, but I tried to put in there all the different things that you might see. You could certainly have the third root of x on top there. So you could also have written this as 4 third root of x over 3. That is exactly the same. So both of those would work. But anyway, so I have a problem here that I want you to do on your own. It's kind of bringing everything together that we've done so far into one problem. So let's see if you can do that problem on your own. Hit pause, really try and do this, and then hit play when you're ready to see if you're getting it right. So when you did this problem, again, always rewrite it first so we can get it in terms of power, so that way we can use the power rule. So this one stayed the same. We changed 1 over x squared to x to the negative 2. We changed the root to x to the 3/4 because it was the 4th root of x to the 3rd. And then the last one stayed the same. Then we applied our power rule. 4 times 4 is 16, lower a power. We did negative 2 times 1 is negative 2, lowered the power. We did 3/4 times 1, lowered the power, and then 5/3 times 1, and then lowered the power. Now don't forget, any negative exponent and any fractional exponent should be rewritten as a positive exponent and or a root if needed. So this was fine, it stayed the same. 2x to the negative 3 turned into 2 over x to the 3rd. The 3 stays on top, the 4 goes to the bottom, or stays on the bottom. The x to the negative 1/4 goes to the bottom and changes to the 4th root. And then the last one, 5 and 3, stay on top and bottom, and then this changes to x, the 5th root of x squared. So remember, the bottom is the root, the top is the exponent. It was not a negative exponent, so it stays on top. Okay, so again, look over this again if you need to. Don't forget to take your Edmodo quiz if that's been assigned, and I will see you in class.